Okay. First case is that if the body is moving or it is traveling fixed distance in fixed interval of time. If a body is going with a variable distance, change in distance is variable with time. Okay. And the another thing is the third case is that if a body is just moving like this. So I'll start with the third case only, though I have said that body is moving. Okay. But in the third case, if you see that if it is a horizontal line, it means that with respect to time, time is continuously increasing, but distance of that body is constant. So distance time graph and displacement time graph have no difference. That's why I'm just using D. This D, if required, you can consider it as displacement also. There will be no difference in the graph. Okay. So when I talk about the third graph, in the third graph, distance is not changing with time. So we can say that body is at rest. For example, if you guys are just sitting here and you'll be sitting here for next 20, 25 minutes. So time is changing, but your distance is not changing. So this will be the graph for that situation. Then moving on to the first graph. In the first graph, we can see that at equal time intervals, the change in distance is equal. Okay, so this will be the graph of constant velocity or constant speed. Okay, it will be constant velocity if it is a displacement time graph. If it is distance time, then we call it as constant speed. Okay, velocity is more often used. That's why I'm writing that. And the last one is it is traveling unequal distances in equal interval of time. It means it is non-uniform velocity. And since it is having non-uniform velocity, this second graph will show us acceleration. Okay, what type of acceleration will be there? That is a later part. Okay, but it will show us that body is in accelerated motion. So whenever the body is moving at constant velocity, acceleration will be zero because constant velocity means with equal interval of time, the distance travel is same. Let's say if you are moving at a speed of 10 meter per second. So in every second, you are traveling 10 meter. And if you keep on traveling at 10 meter per second for next 20 seconds, then we can say that you are moving at a constant velocity. So you're not at all accelerating. Acceleration will be zero in that case. Next is when we say non-uniform. So non-uniform is clearly indicated from the curve. So whenever there will be a curve, it will be a non-uniform velocity, and non-uniform velocity means we can say that there will be an acceleration in the system. And third one is a very simple case. Distance is not changing with time, so the body will be at rest. So we can call it as zero velocity. So first one is constant velocity. Second one is non-uniform velocity. Third one is zero velocity. Last thing for distance time graph is that gradient of a distance time graph gives velocity. Okay, I'm being very clear one more time. When I'm saying velocity, velocity is true for displacement, not distance. Okay, so when it will be a displacement time graph, the gradient will give me velocity. If it is a distance time graph, then it will give me speed. So keep that thing very clear. Speed and velocity are not different. Gradient will be like you can see for the first graph, this line is going constant. Okay, so gradient will be same for all of them. That's why I'm saying that it will move at a constant velocity. Then in the second graph, if you look at the curve, it has an increasing gradient. Increasing gradient means literally the velocity of this body is increasing. And the third one is hopeless in that scenario because velocity itself is zero. So gradient will also be zero in that.